Hello, my name is Heiko Seitz, and welcome to my presentation, OPC UA takes AI to the field level. I'm technical writer at IDS, and today I will show you how easy it is to integrate an edge intelligence vision system into the field level of an OPC UA-enabled industrial facility. Before I get into the topic, I would like to introduce ourselves briefly. IDS is one of the world's leading manufacturers of digital industrial cameras based in southern Germany. We have been creating components for industrial image processing since 1997, and all products are developed, programmed, produced, tested, and shipped worldwide entirely in-house. Our portfolio ranges from classic 2D cameras to 3D active stereo vision cameras, and also cameras with integrated AI-based image processing. For today's topic, vision integrated automation, I would like to talk about the last mentioned category, our IDS Next camera series, because it's not just another image provider to build a vision system. The concept and the companion software package make this edge computing device a complete vision system that can be used as easily as a smartphone. Because we believe that our goal must be to consistently develop industrial cameras and image processing products for the industry and to make them easy to control. And this also includes the new field of AI-based vision. Recently, I read the following. The ideal sensor for Industry 4.0 is flexible in use, offers a wide range of functions, and has future-proof communication technology. We agree with all this and see two major challenges for the integration of an AI-based image processing into the manufacturing automation. The technology must be easy to use without any special knowledge, and the autonomously working systems must be able to communicate directly with the other components. So OPC UA is clearly an ideal forerunner here for integrating image processing systems and even small edge devices into industrial applications easily and without much effort. I will now show you how all this can work. For this purpose, I would like to show you first how AI can easily be used to generate process-relevant information. Because AI has indeed moved very much into the industry's focus, but who knows about it? And what skills does the industry need to build up in order to use the new technology? On the way to a trained network, there are some challenges to pass. One of the biggest is in the area of knowledge. So how to program or build a CNN, to choose the right model architecture that best fits with the task, or to set up the right hardware to train the networks. These issues are the main reasons why CNNs are often not yet more widely used in the industry. With an all-in-one inference camera solution, IDS Next Ocean, we have addressed exactly these challenges. So, for example, the cloud-based training software IDS Next Lighthouse encapsulates the whole AI special knowledge. And you as a user only have to worry about the data delivery. And for the inference execution, there is the IDS Next camera family, an edge AI platform that performs CNNs in a hardware accelerated but energy efficient way. You become the user of a system that relieves you of any specialized knowledge and yet provides you with maximum support. With no prior knowledge of artificial intelligence or application programming, you can build up an AI classifier with your own images which is then ready to run on IDS Next cameras. The workflow itself is simple and complete. You take pictures of an application or of your application objects that you want to detect or to classify. Then in IDS Next Lighthouse, these images are categorized by labels to generate the required data sets, such as good ones or bad ones. And through this step, the AI learns from your knowledge and can later apply it to new images on its own. And this is the basis for the inference. And then you only have to start a fully automatic training of your neural network. With the configuration tool, IDS Next Cockpit, you can load the trained network into the camera's memory. Together with a vision app, the neural network can immediately be used for your image analysis. In this example here, the camera is now able to classify apples like you would do that, and the inference results in probabilities for the trained categories. Now here we have faulty apple, and we get a probability of 34% for a not okay object. In order to execute the extremely compute-intensive CNNs in an efficient way, but still with a high performance on a small edge computing device like a camera, we have developed a CNN accelerator that works as an IP core in an FPGA. We call it the DeepOcean core. So we achieve a very high power efficiency compared to other acceleration solutions such as CPUs, GPUs, or even full ASIC solutions based on, for example, Intel Movidius AI chip. The FPGA implementation allows us to further develop the DeepOcean core and update also cameras that even already in the field. The accelerator works with many well-known image classification networks, such as MobileNet, SqueezeNet, or EfficientNet, and achieves high frame rates up to 67 frames per second. Through the all-in-one solution consisting of training software, well-chosen CNNs, and a self-developed AI accelerator, you can even specify the desired inference time during the CNN training. So IDS Next cameras are really easy to use and provide an universal edge intelligence for the industry and many other markets. Thanks to the app-based concept, the use case of the camera can be changed at any time. With the Vision App Development Kit, your developers can also easily design their own apps, specifically for your application. But how can an embedded vision system be integrated into industrial applications? Let's remember what we said earlier in this session about the ideal vision sensor, that we were talking about a future-proof communication. So let's have a look at the interfacing options. With IPsec7 protected connectors, digital in and outputs, two-wire communication and Ethernet, IDS Next cameras can be used very flexible. A stateless REST web service enables connection to all web-compatible devices in an IoT network structure. It is not only used for data and result transmission, but also for the installation and configuration of apps and interfaces. OPC-UA is just such a vision app that can be installed via the Cockpit's app manager by simply selecting the app, uploading it, and activating it. And this is how easy it is to update an IDS Next camera with forward-looking components for seamless integration in factory automation. The OPC UA plugin integrates an OPC UA server, the cameras, making their AI capabilities available in the OPCU network, respectively your field level. With the OPCU machine vision companion specification, the cross-manufacturer and cross-industry communication technology also provides the ideal interface extension for IDS Next cameras to easily use AI-based recipes in factory automation. So OPC UA is the ideal complement for us to make the vision app-based inference tasks accessible in the industrial environment. Unlike our REST camera interface, for example, the OPC UA specification does not provide any standardized function calls for the device manufacturer's specific procedures. This would not be a good thing because image processing systems are hardly comparable in terms of their control, mode of operation, and the settings and data used. So it would be very difficult to create a standard from this without limiting the very individual systems too much in their functionality. This means that unique selling points for us, device manufacturers, remain possible, and the OPC UA communication remains lean and scalable. The available device services, in our case, complex processing tasks, are encapsulated by OPC UA in function blocks, so-called recipes. Their exact mode of operation does not need to be known by the automation engineer or the user for PU use. Similarly, necessary and sometimes very in-depth settings for special applications are summarized and stored in configuration datasets. So without having to know these specific device-specific settings in detail, these presets can help to use the device for the execution of special tasks. This simplifies the integration processes and commissioning of new devices in an application workflow. To set up a recipe task and configurations on the camera, the manufacturer's specific interface is used. In our case, this is REST. However, the IDS Next cockpit can also be used here with existing vision apps without any programming effort. This simplifies the setup immensely. Here we see, for example, how a classification of objects is set up with a pre-trained CNN. And via the integrated OPC UA plugin, the camera settings and inference tasks can be saved with a descriptive name. And with this, the OPC UA setup of the camera via the cockpit is already done. That's all. Especially for embedded vision devices such as our inference camera, OPC UA is the perfect language to communicate in Industry 4.0. With the integrated OPC UA server, their services can be made available to every client in the industrial network via recipe and result management, for example. They work then more like a vision sensor, not as an image provider, but as a result provider. In addition, they offer variable information of many possible vision tasks in the OPC UA environment, thanks to the open app-based system. Results can thus be communicated directly within the field level or directly to the machine and control level. With vision apps such as Classifier or Object Detector, turnkey solutions are already available to classify image components or identify specific objects using artificial intelligence. Developers and AI specialists, on the other hand, can dive even deeper in the system with the IDS Next Vision App Creator SDK, and thus adapting the cameras even better to their own needs. The design possibilities and application options are therefore very versatile. I would like to show you a proof of concept of a customer who has, start the video, of a customer who has developed his own interface app to realize a direct communication of the camera with a robot using the XML RPC protocol. After the recognition of the object, the camera sends direct control commands to the robot where the object can be picked up. And all this function works without an additional host PC. So to summarize all this, to bring the AI to the field level, our goal is to provide a simple usability by already integrated professional knowledge, a great variety of use cases through the app-based platform, future-proof communication technologies with here OPC UA, and all this in a small edge intelligence. This saves time and costs in automation and ensures a rapid integration into industrial facilities. OPC UA brings us the ideal interface extension with the OPC Machine Vision Companion specification to easily support factory automation with AI-based recipes. And with the all-in-one inference camera solution, IDS Next Ocean, we can help you to bring the AI-based image processing and the mechanical engineering finally closer together. So thank you for listening. And if you have any questions, you're welcome. Thank you.